Welcome to TTB's Stage 4 Parallax run-through of the matrix image maps. The 3x3 on the upper one and the 3 columns on the lower one. By the end of this video, one will find answers to website performances when it comes to device DPU and user maximums. Now let's get to it and start out by emphasizing on A1. So we have this. First we're going to do a little click back and forth, and now we are back at the central base B2 matrix here in the middle. So first of all, we are going to press on the A1 in the top left corner. And one can now see that we have an object speed, O-speed at 32.8 kilometers per hour. And then we have a target speed down here at 40 kilometers per hour. These are the two upper text fields. And one can tell that up here we have a drone that is, well, it looks like it's the same height as the object or the target, but we are in a position where the graphics are a bit clustered together up there. Now the video went back to the base where we have our 50 feet target height, and we don't have an observer speed and nor a target speed. So that's the base. Otherwise, if we go back to the A1, this is the mandatory speed for the object up here, 30, and the target speed is 40 kilometers per hour. Moving into the A2 matrix area. So if I click on the A2 area like this, one can tell that there is an icon below the target icon in front on the image map up here. Things are becoming quite cramped together because there are only these 9 matrix areas. A1, A2, A3, and B1 to B3, and C1 to C3 in the bottom. Here one can tell that the observer speed, being the Challenger plane, is around 350 kilometers. And right now it actually reset it due to the cycles and seconds down in the middle. If I click here again, we get back to seeing the speed, the O-speed in the top. At the A2 option, the target speed will always be 0 kilometers an hour, whereas the target height will be between 2,400 feet, as seen down here, and then at the maximum at around 3,400. And now you're seeing that the speed at times can go down for the observer speed up here to around 8 kilometers an hour. Then the user has to reset, or you have to reset and then try again up here to see the correct speed up here. As one of the special terms for this option is that it doesn't look like the observer speed is moving very fast. But one has to rely upon that the zoom effect from the mounted camera towards the target makes it look like they're very close. but in fact they are 3,500 feet between the Challenger plane and the target. Now, if we look upon the A3 of the matrix, the upper right corner of the 3x3 matrix, if I click on that right now, one will see that there is a jet fighter airplane icon in the background. And in this option, the jet plane is flying with a observer speed of 555 kilometers an hour. It is quite slow, but it's still much faster than both the drone at the A1 and the Challenger plane at the A2. The target speed is here at around 800 kilometers an hour. So actually right now we are in a situation where the sea surface reacts to a target speed that is higher than the actual observer speed. And now the system resetted, going back to a target height of 50 feet and a target speed of 0 and an observer speed of 0 kilometers an hour. So if I click A3 again, one will see that again the heights are between 3,400 feet at a maximum, and then at the lower end it is around 2,400 feet for the target height at a minimum. Moving on to the B1 area, which I will click right now, is actually an option where you have an observer speed, being the drone, of 250 kilometers an hour, and then you have a target speed that is 87 kilometers an hour. Due to the height of that is still quite high, being 2,000 feet, the sea surface is almost not moving, and that is due to the actual height difference between the target height and the sea surface. If one will look upon the difference between the B1 clicked now and the B2 clicked now, one will see that there is actually differences that can be made within that little, or within that small B2 area in the middle. And that is that even though that the helicopter is loitering above the target, the red orb, there can still be differences in the height. So the top height will be at around 2,300 feet, and the bottom height will be at around 1,600, maybe 1,500 feet in height. The reason why the icons here display a helicopter that is loitering in its place, and the reason why these icons are red, is that you will very seldomly find an object that is loitering or is at a standstill, a stationary position in the middle of the ocean. Furthermore, you would not find a helicopter that is observing the target and loitering in its place. So and again, now it's resetting to the main state where the height is only 50 feet. To put an end or to conclude around the red icons, it is a very deliberate kind of case, which has nothing to do with parallax. One has to have movement from the viewpoint position in relation to a target that is being observed and one of these targets has to move in order to get the parallax effect. And that is why these icons are red, as being a very unlikely scenario. Alright, so let's move forward, and we are now looking upon the B3 area, and here the observer speed, the jet plane, is moving at a rate of 850 kilometers an hour. The target speed is actually quite a bit more than that. It's around 1300 kilometers an hour. And again, we can move up and down with the actual observed height, the target height. And right now it is at around 1470 feet in height. Moving on to the C1 area, I'll click down here, and one will see that again we have an observer speed that is comparable to a drone, as seen in the top. The drone has a observer speed of 220 kilometers an hour, and the target speed is around 11 kilometers an hour. So this scenario is actually similar to a balloon that is hovering above the sea surface. This is also similar to what is seen when a bird is moving across the sea surface, or close to a bird moving across the sea surface. Again, it doesn't appear that this would be a bird or a balloon, but one has to remember that the target height is roughly 900 feet above the sea surface, so therefore very little parallax effect is shown. Let's look upon the C2 area. So if we had the C1 area over here, then we also have a C2 area to the right of it, right here. So this area is actually for a Challenger plane speed of 400 kilometers an hour, approximately. And the target speed in this case is around 216 kilometers per hour. The target height is around 600 to 700 feet, and one can tell that there is quite a lot of movement in the background on the sea surface. So even though we are at a height of at around 700 or 650 feet, there is quite a lot of parallax effect in the background. And here the system is resetting once again. So if I click on this, one can tell that now we are down at these heights between 1000 feet, and at the lowest we can go all the way down to 316 feet, or even below 300 feet. And one can tell that there is a lot of movement in the background. The closer the target gets to the surface, the target gets to the sea surface. Now this will be even more pronounced if the target speed is around 400 kilometers an hour. So both of the observer and the target they are both moving quite rapidly, and that makes for a large parallax effect in the background that is given from the sea surface patterns, wave patterns. The target height is around 300 feet here, but it can also go up to around 1100 feet, and then the parallax effect is smaller. Okay, so now we are going to look at the lower image map down here, where we have the magnifying glass and also the airplane icon. So if I press in the center of the first column, the L1 column over here to the left within the image map, one can tell that we have this object, the observed target, and it has a yellow ring around it if I zoom in, and that is to better emphasize and to show to you as a user which direction the object has in correlation to the observer, to the mounted FLIR camera. But if we go further and want to obtain a observer and target speed from up here in the image map above the upper image map, and then press down here with a circular routed scenario, the parallax effect is making a circular motion for the sea surface below. In case this functionality, this application, state for parallax, goes into a somewhat viral state, the sole file and application will not be sufficient, will not suffice in order to meet the demands of many users. Therefore, extra and additional folders and files, actually 9 mirrors in all, being 10 folders total, will be available so several users can use the application simultaneously.